Hello, algebra friends. Okay, so we spent a lot of time, 2 weeks on exponential functions, and it's time to bring it to an end. So what we're going to do is a little graphic organizer that highlights everything from this unit. And then on Edmodo, you're going to see a 10-question quiz for us to get a little grade from you, and then we can move on to new stuff next week. All right, so on a clean piece of paper, we're just going to do a little summary here, and you can use this during your quiz, by the way. So I would say have it ready. Okay, so when we first met in January, we were learning about linear functions. All right, linear functions, those are graphs that just make those straight lines. And those equations are considered linear because the variable has a power of 1. So for example, it would look like 2x plus 3. All right, so notice your variable, x, has a power of 1. That's what makes a linear graph. Then we got into something called quadratic functions. Quadratic functions. With quadratic functions, those made those U-shapes. We call these U-shapes parabolas. An example of an equation that makes that picture looks like this, like 2x squared plus 9x plus 3. All right, so what makes this a U-shape is the fact that you have a power of 2 in your equation. All right, so now this section was getting into something new, and it was exponential. Exponential functions. All right, so exponential functions, we call them J curves because they kind of look like a J, right? It just kind of shoots up into space like that. Kind of looks like a boomerang to me. Anywho, we've got these exponential functions and asymptotes that these lines can't cross or touch. The reason why it's an exponential function is because the variable is now the exponent. So for example, you might see it like 2 times 4 to the x minus 9. All right, so what makes this J curve is the fact that we have a variable as the power. All right, so getting more involved, we started graphing. Now, so I'm going to work with this little guy that I just wrote right here. So this 2 times 4 to the x minus 9, right? All right, so this is an exponential function. Let's practice some vocab here. The number that's in front, all right, that starts this whole thing off, we call that the initial value. On a graph, initial values are at the y-intercept. All right, so that's where it crosses on the y-axis. Then the next piece that we have is in parentheses. This is the base. If your base is larger than 1, then you're going to have exponential growth. If your base is smaller than 1, like a half or a fourth or a third, then you're going to have decay. All right, so since this base is greater than 1, we would say that this is growth. All right, and then the last little guy here at the end, this minus 9, that's going to let you know where that force field is, where that asymptote is. All right, so it's going to be at this y equals negative 9, right? On the y-axis at negative 9, that's where that little dot, 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 dot's going to be, and your J curve is not allowed to touch it. All right, so we've got the initial value at the beginning, the base with your power as the exponent, and then minus, that will be your asymptote. Remember, your domain on these is just like the domain with all the other functions we've done this year. It's all real numbers. You can put anything in for x that you want as long as it's a real number. What other numbers are there? Well, there's this thing called imaginary numbers, and you'll learn that in algebra too. Okay, then the second thing is your range. So that describes the y-axis. It's directly related to that asymptote. Since it is growing, we would say that range is greater than that asymptote line. All right, so then the next topic is a compound interest formula. This one's really useful in the real world. Compound interest. They use these equations when you're doing investments at the bank, or when you're taking out a credit card or a loan, or if you want to buy a car. So this is something you should really be familiar with. So let's say you are investing, I don't know, how about $15,762? Look at you. Nice investment. We're investing it into an account that has an interest rate of 2%. And we compound it, let's say, monthly. All right, so let's take a step back and just kind of highlight what I just wrote down. So the number in the beginning, right? Let's say this is your account, A for account. The number in the beginning is your investment. We call that the principal. All right, it's also known as the initial value. All right, that's your y-intercept for these graphs. Inside the parentheses is where you're going to find the interest rate. So the decimal up here is your interest rate. Okay, so 0.02. If you want to put it as a percent, which is how you usually see it when it's advertised at a bank, for example, if you want to use the percent symbol, then you have to move your decimal 2 places to the right. So 0.02, that's the same thing as saying 2%. So this is a 2% interest rate. The denominator tells you, well, how often do we get this interest added to our investment? So 12 here, that means it's going to happen every month. Right, it compounds monthly. That's why we use 12, because there's 12 months in a year. Compounds monthly. You'll notice that this number is also used up here because T stands for time, and you might do this for, who knows, 10 years. So you're going to do this 12 times per year for 10 years. So that 12 gets put in both places. Other types of compound words that you need to be familiar with would be quarterly. All right, if you were compounding quarterly, then this denominator would be a 4, right? 4 quarters. If you were compounding, how about annually? Annually, that means it just happens once a year. So that denominator would be a 1. What else might there be? You could see daily. If you compounded daily, how many days are in a year? 365. So that denominator could change based on the wording. All right, so that's your compound interest formula. All right, the next thing you have to know is solving. All right, so that's when we were playing around with the bases. So for example, let's say you have 2 to the 2x plus 11 equals 8. All right, if we want to solve this, we need to get the bases to be the same. And right now, this does not match this. So let me grab my handy-dandy calculator so I can play around with different ways to rewrite. Okay, so if I did 2 squared, that's not 8. If I do 2 to the first, no. 2 to the 0, no. 2 to the third, there it is. 2 to the third is another way of saying 8. So we can rewrite this 2 to the third. Gave it a new hairdo. It's still 8, just with a ponytail. All right, so then over here we have 2 to the 2x plus 11. Since your bases are now the same, we can ignore those giant 2's and just focus on the variable up here. So we have 2x plus 11 equals 3. And then it's some good old-fashioned algebra. The opposite of adding 11 is minus 11. So 3 minus 11 is negative 8. And then bring down this 2x right here. Okay, the opposite of 2 times x is to divide it. And that'll cancel. So negative 8 divided by 2 is negative 4. You can check yourself if you plug this back in. 2 times negative 4 is negative 8. Negative 8 plus 11 is 3. So 2 to the third power is 8. Yay! All right. What else do we need to know? We need to know how to write the equation. All right, write the equation. So we've got the equation a b to the x. Right, that's the general form of these exponential equations. You're going to be given a table, and this is what we were doing yesterday. Let's see. Let's say we have negative 2, negative 1, 0, 1. 6, 18, 54, 162. Okay, so remember the x values, they're kind of boring. It just goes one after the next. It's the y values that you're going to see the pattern, right? You're going to be able to see that rate. So going from 6 to 18, that's times 3. 18 to 54, that's times 3. 54 to 162, that's times 3. So that's going to be our base, right? We're multiplying by 3. The a is your initial value. So the initial value, that's when the x is 0. So that would be right here. So my initial value is 54. So your equation would be 54. The base is going by 3 to the x. That's all there is to it. So look for where x is 0 to get your y-intercept. That's your initial value. Look for what the pattern is. That's your base. And then the variable is the power. All right. One last thing that we have to be able to do is average rate of change. Average rate of change. All right. Average rate of change. That's a very fancy way of saying slope. So the slope formula is y to the sky. You have y2 minus y1 over x2 minus x1. All right, you could be asked to do this formula on a graph or off of a table. So let's practice on a table, shall we? Okay, so let's say we've got a table, -3, -2, -1, 0, and then the output over here is 1/3, 2/3, 4/3, 8/3. All right, I want to know what the average rate of change is from -2 to 0. All right, so if I want to know from x is -2 to x equals 0, what I recommend doing is scribbling out all the other values. We don't need you. We don't need you, right? We just want to focus on -2 to 0 because that's what the problem would be asking for. Okay, so the x's go on the bottom. So the second x is 0 minus the first x is -2. And then on top, we have to do the y values. So the second y value is 8/3 minus the first y value is 2/3. If you have these fancy pants calculators, you could type it in literally just as you see it. If you don't have a fancy pants calculator, you might just have to take it piece by piece. All right, I'm going to assume that maybe you didn't get this calculator. So let's see what it looks like if we have to do it by hand. 8/3 minus 2/3, since the denominators are the same, just focus on the numerator. 8 minus 2. 8 minus 2, that's 6. On the bottom, 0 minus minus. When you have minus minus, that turns into a plus. Okay, 6 divided by 3. 6 divided by 3, that's 2. So now we have 2 on top and 2 on bottom. And what's 2 divided by 2? 1. So your average rate of change from -2 to 0 is simply 1. All right, so there you have it. That's everything you need to know for your Unit 4 quiz. Make sure you have this handy. You can use it as you go through it. And I look forward to talking to you Monday.